So if someone wants to become a senior solutions architect, so what will be the mindset shift he needed?
The biggest mind shift changes is needed is you should start thinking about why we should build it instead of focusing towards how we should build it.
So let's come to the next question. It's about AI. So you hear a lot of things going on in this internet or in this era, right? AI is everywhere. So what are the myths about AI, you think?
The biggest myth about AI is going to replace the developer. That's not true. Whenever there is a new technology comes in the market, everyone thinks that this technology is going to replace this one, but that's not true in the past. When the computer came into the market, people was talking about computer is going to replace a human, but that doesn't happen.
Have you ever wondered why good code still fails in the real world? Or sometimes why teams make systems way too complicated? Or what about spending months to building a feature just to find out clients don't even use it? It happens all the time, right? We get focused on the technology so much that we forget the actual problem we are trying to solve. Welcome to this podcast. I'm Pratik Mankar from Team Accucia. Today I'm sitting with Mr. Chhota. Mohammed is a senior solutions architect at Accucia Softwares. From over the last 10 years, he has delivered around more than 150 projects. So without further ado, let's have a conversation with Chhota. Hello, Mohammed. Welcome to this podcast. It's really great to have you here. My first question is, can you please guide us through your journey in the IT industry from a junior developer towards the senior solutions architect? What was your journey?
Thank you, Pratik, for having me here. I would like to give my journey, like how I transitioned from junior developer to senior solutions architect. I started my journey as a junior mobile developer. I used to write mobile applications. When I started, the Java was there for developing the mobile applications. So I was writing the mobile applications in a Java. I tried to solve small things. My responsibility was to write a code to how to fix the bug to meet the deadline. At that time, success for me was to meet the deadline to writing the clean code. Over the journey, I have worked on many different things. I started working on a Kotlin, then I moved to the Xamarin, then I have worked on a Flutter, and eventually I started developing interest toward the backend technology. I started exploring the Next.js, Express.js, and I started exploring how the system should be built, where it handles the scale. So I started exploring the cloud technology, such as Google Cloud, AWS Cloud, and my interest started focusing towards what it needs to build a successful software. So my journey was begin from the junior developer, and then eventually, as my interest grown into the many other things, I started exploring the new stuff, and I started learning the new stuff, and eventually I landed to the solutions architect role.
Yeah, that's really interesting. So looking back at your journey, was there any specific moment or an app or an event which completely changed your mindset and which eventually led you to become a senior solutions architect?
I work on multiple different domains. I have worked on finance domain, I have worked on healthcare domain, I have worked on manufacturing domain, I have worked on hospitality domain. So over the period, I have developed many software. But what I realized, software doesn't fail just because of the code. It fails because of how you implemented that software.
Because of bad strategy.
Yeah, that's correct. Software fails because of bad strategies. How you have implemented a software. That is also one reason that software is getting failed. What I realized, when you don't understand human behaviors, it's going to get failed. It's not going to be usable by the users. So when you are developing a software, you have to make sure that it should be usable by users. Instead of asking these questions like how I should build it, we should ask questions why we should building these things at the first place. If we answer those questions, it will become very easy to develop any successful applications.
Right. We see a lot of good system fails in the market. So what do you think? What could be the main reason behind that?
A system get failed not just because of bad code, it's because of bad strategies. How you have implemented your software matter a lot. Before you build anything, you should ask questions. Whatever we are building, what is the use case behind that? What problem we are trying to solve? How we are making users' life easy with this software? Is there any real value what we are building? If we answer those questions, and after that if we develop anything, it will be usable by the users. If we develop anything without answering those things, there might be chances that you are going to develop something which is not usable by the users. We need to understand users' behaviors. What users is trying to do with your software. Whatever he's trying to do, Are they able to achieve those end goal or not?
Yeah, I think I would like to add a few more pointers here. Like when we are building a software, so it should be a solution of a pain points of a customer, right? So when we are doing something, we are building something, we should understand what are the pain points, what are the problems which are facing customer, and that software should be making the life of that customer easy. It should be very accessible, it should be very user friendly, and and it should solve the real world problem, right? So let's come towards the next question. What are the biggest wrong assumptions teams make?
Before starting any software, people assume that customer want these things and customer want that features. Before even talking with the customers, that's a biggest misconceptions. We have to first understand the requirement. Business doesn't want a big software from day one. Once business start using software, they will require some features. If you understand the business requirement and if you develop it accordingly, that's going to make us successful. One more point I want to highlight over here is people try to build massive software from the day one. That's not going to work. If you check any software, if you take example of Facebook, if you take example of Instagram, if you take example of any other ERP product or CRM product, that's not like what they are today from the day one. They have evolved with the customer feedback. So when you are starting software, make sure you are building only those things which is business critical. Whatever the business critical things, you have to develop first and you have to ship first and take the user feedback. Once you receive the user's feedback, you iterate on those things. Don't try to make too many things. If you try to make too many things, then it will be complicated for users to understand and users to use it. And for developer, it will become messy and unreliable and not maintainable.
Yeah, so that point I really like, that everything should not be started from the day one. So software should be developed from the phase wise, right? So first phase will be what are the bare minimum requirements, what are we delivering, and is it solving the problem of customer? And then we'll eventually get the feedback from the customer, and then we'll scale the software, right? So sometimes developer makes a mistake that while building a software, they might think that client might need this, but they really don't need this. They don't even use it, right? So that's really good points you have told us, and will definitely help other viewers which are watching us. You have developed application in so many domains, right? So across them, what are the common things you realize that what made them successful?
Have developed multiple applications. Many of the applications are very successful. So what I realize, if you try to solve one problem at a time, then that applications or that software becomes successful. If you try to solve too many things, eventually it will confuse users. So we have to solve one problem. We have to solve in the way that it can be helpful for users. Solve one, go deep, understand what pain point user having, understand how we can improve on that part. So mastering on one thing is required. What I realize, like when you don't do that things, when you start doing many things, it will divert your focus. It will divert what you are trying to build at the first place. And user will also not able to understand what you have built. So if you build a software that is focused, then user is going to search for that tools. If they face some problem, similar problem, they are looking for the solutions. Then they will come to they are going to use your software.
Yeah, you correctly pointed out some things which really impacts. There are some things like the development phase, the deployment phase, the testing phase are really common, right? So where we should take requirements, where we should deploy the product, or what things to be deployed, that really matters to be a successful software, right? So my next question is, sometimes we think that we develop one product, right, or one software, and we think that a customer will use that product the way we expected, but they don't. So what are your thoughts on this?
When you build any software, you will get surprise, when you build any software, you will get a surprise how the user are using your software.
Right.
There are many different ways that user is going to use your software. Whatever features you love most, it might be common that user is not going to use that features. Sometimes they try to use a small features that you have not care about. But that is a part of the software journey. You have to understand that things, that what user is liking and what user is not liking. And based on that, you have to develop your next things. You have to embrace what user are using it. You have to improve on that things. You don't have to tell like this is what I have built and you have to use it. No, user is not going to think on that way. User is going to surprise every time when you launch something new.
Right. I think the real testing is when we deploy it on production, because the real users are going to use it. We cannot assume like what traffic we can. Yeah, we can definitely assume that what metrics we can define a metrics like 500 people going to use it. But when we deploy it on production, the story is something else, right? So the real testing area or the testing ground is a production, I believe, right? So what are your thoughts on it?
As you mentioned, the real testing ground is productions. That's correct, Pratik. Whenever you deploy some software, people are going to be tested your software. They are going to find a different ways to interact with your software. They are going to see what is you have built. They are going to explore your software that you have not intended to. So that's a thing that is going to happen when you deploy your software on productions. People might face a problem like when you have developed your software, you have tested that software on your environment, but people might be using on different environment. They might be running your software on mobile applications. They might be running your software on the web. They might be having 2G. They might be having 4G. They might be from different regions. So every time when you deploy anything, there might be different scenarios that you cannot able to replicate at your development environment. People will face problems. You have to be ready with that things. You have to be ready with what scenario that user is going to come. You have to be understand like what sort of problems users are facing with your software.
Right. So we talked about the users using the product, right? So here's my question: like we talk about scale, we could talk about performance. So when do you think that our products needs a scaling?
As a senior solutions architect, I don't think guesswork is going to work over here. We have to rely on a matrix. We have to set up some matrix. We have to set up logs. If your logs and your matrix is telling you that this system is needed to upgrade, then only you have to upgrade. It's not a thought, it's not your assumptions that this system needed upgrade or not. You have to set a benchmark. If certain benchmark is getting hit, some threshold is getting reached, some performance is getting delayed, you have to act on that part. You have to measure how much CPU utilization is taking, how much GPU utilization is taking, how much RAM utilizations you have, your software is taking, how much latency each API is taking. So when you understand those things with a good quality matrix, and when you define a threshold, it will become very easy to take a decisions when to scale and when to not. Apart from that, there is some predictive analysis. Like you have to set up some predictive model which will give a signal where system is going to get crash after this much traffic. So you have to act on that part. Apart from that, if there is some event is going to come, we have to plan that event in advance. We cannot do delayed planning. If we have planned it in a better way that this is going to get traffic in the next couple of months or next couple of years, if we have a plan, then we can able to execute it properly. Without a plan, if we are doing upscaling and downscaling of the system, that is a wastage of money and that is a wastage of time.
Right. So we should define a certain metrics or a certain point where our system should get scaled. So initially, if we deploy our software, so we should gather some analytics from user. Since it's an initial deployment, we cannot guess that this much traffic is going to come on our server. So we should get analytics from the users or the customers. So we'll get better idea, right? Let's say 500 users are going to use my software. So we can predict that and we can set the benchmarks according to that. And we will set the environment or the scaling thresholds, right? So yeah, that's really justifies the answer. Throughout my journey, I was very enthusiastic back in these old days. So I was assuming that we can do this, we can do that. And sometimes it was getting over-engineered. And sometimes it was getting under-engineered, right? So I thought that at that point, we forgot like what we are building, what we are trying to solve, which problem we are trying to solve, right? So can you please tell me, like you have a team, right? So where does this team mess up most? Was that under-engineering or over-engineering?
Under-engineering and over-engineering, both the things are very bad. You have to plan what users needs. If I give you an example, like what kind of problem users create when they do over-engineering. They try to provision too many servers. They try to assume too many features that users don't want. They try to build a complex systems. They try to build a system from the day one which is complex. Our engineering is a very bad. Like I would like to tell example, like when the people do our engineering, they try to build too many things at once that which user don't want. They try to provision too many servers. They try to make the system architecture difficult to understand, difficult to maintain. They are thinking about scale from the day one. They are thinking about million users. If you don't have a million users, you don't have to provision for million users. You don't have to give the infra for million users. Whatever users you have right now, you have to plan it like how your user is going to use your applications. And many of the time, when engineers are under pressure, they try to cut corners. They try to cut certain things. They try to cut testings. They try to do the performance testing, vulnerability testing. They try to ship faster. But that is also important. If you have to do the proper planning, you have to do the proper testing, and then only you have to put that applications on productions. If you don't do the engineering properly, if you do the extra engineering, or if you do the under engineering, that is very bad for the business.
So this is a very interesting question I'm going to ask you. So when a person gets promoted to a leadership role, so there are some mistakes they do, right? So what are the common mistakes you think they do?
What I see is the first time leader do the mistake is they try to do everything by themselves. They think like they are the smartest people in the room. But leadership is not about that things. Leadership is about trust. Leadership is about letting go. Leadership is about giving control to your team. Leadership is about allowing your team to perform best. Leadership is about guiding your team to do their work proper way.
They don't focus on the team, they focus by their own.
What I see that the leader make mistake is they try to achieve everything by themselves. That's not going to work it out. If you are become leader, then you should allow your team to perform well. When you become leader, you have to change your focus from writing code to understanding the business requirement, communicating with the non-technical people, how you will explain all this thing to the stakeholder. That is required as a leader. You should improve your soft skill. You should understand what business goal is. You have to understand what is the business requirement is, and you have to communicate that back with your team. You have to explain why this thing is required.
Yeah, that's a really good point. It happened with me as well. So when I was a developer and promoted to senior developer, so I was doing a lot of things by myself. I was very new into this position. I was not having that experience to manage the team. So that was very good learning curve for me. So it's really a good pointer you have pointed right now. So let's come to the next question. It's about AI. So you hear a lot of things going on in this internet or in this era, right? AI is everywhere. So what are the myths about AI, you think?
The biggest myth about AI is going to replace a developer. That's not true. Whenever there is a new technology comes in the market, everyone thinks that this technology is going to replace this one. But that's not true in the past. When the computer came into the market, people was talking about computer is going to replace a human. But that doesn't happen. Right now, we don't work without computer. The same way, when AI is coming into the market, people are thinking that AI is going to replace human. AI is not going to replace you unless and until you don't learn it. People who learn AI is going to replace you. AI itself isn't going to replace you. If you don't learn how to build it faster, how to work it smarter, then people who has learned those things is going to replace you.
Yeah, yes, you pointed out it really well. I was also thinking the same in my mind. So can you tell me more about the AI, like where exactly AI will help more?
When you're doing MVP, when you're doing some prototyping, some ideas, over there AI is going to help you a lot. In case of the large data, if you're having GBs and TBs of data, over there AI will help you to analyze those data, to get a proper result from that data. You cannot do that things manually. So whatever fields human don't want to do the work, such as customer support, AI is best at that things. People don't want to do that work. Whatever the work human don't want to do, over there we can enable the AI. Let's enable the AI to do our job.
Right, like recurring tasks, you can say, the job which gets repeated, and you mentioned that customer support. We also have chatbots right now. Many of the system have implemented it. Instead of a human replying to our answers, the bot replies to the answers, right? Yeah, that's really good insights you have given us. So looking back at your journey, what thing took the longest to learn for you?
The longest things it took me to learn is no system is perfect from the day one. I was trying to build a software which is perfect from the day one. That is not going to happen. The system is going to get fail. You have to start with the small things. You have to understand that no system is built with the perfections. So instead of going towards the perfections, you start developing something. which should be usable by the human, which should be usable by the real persons. If you go for perfections, you're not able to launch anything. As a leader, you should have a good communication skill. You should know how to resolve conflict. That also took me a longer time to understand. There is a many soft skills which need to be developed as a leader. That will take time to learn. That will take time to learn and master. But as a leader, those things are required. We have to understand how we should communicate with a non-technical client, how we should understand the requirement from them. That also took me some time to understand.
So you have built more than 150 applications, right? So I want you to point out few of them, like which you taught you most to learn.
As I mentioned, like we have built 150 plus applications. That is, every application taught me some new lessons. If I talk about my journey, I have built one application which is currently used by millions of users.
Yeah, that's Adbana, right?
Yes, that is Adbana. So over that time, what I learned, you should start with the small things. When I started that applications, we have started with one very small things. That is, we should enabling users to easily create images and videos. So that small things we have developed and we have launched it. What we have seen is like after we launch it, we immediately start getting user attractions. Users start giving input to us. What things we should build, that user is telling us. If we listen users' feedback and we start developing on that part, that system become big. That applications will become big. Eventually, we reach to the millions of users. There is performance bottleneck also going to come, because on the first day you are not going to build a software which is going to handle millions of users. You have to change your architectures. You have to plan it in a way that it should scale to the handle millions and billions of users.
Yeah, right. I also wanted to point out here regarding another software you are currently working on, which is Elevator Plus, right? So it's a SaaS product. So could you please explain like how it handles large scale traffic?
You mentioned Elevator Plus. The Elevator Plus is a one SaaS product. When it comes to the SaaS product, there is a totally different game. You have to understand and you have to build a software that should be reliable, that should be secure, that should be scalable. So every business has a different business needs. So we are building this software for elevator industry. So elevator company is going to use it. But when you see, there is a different processes each and every company uses. If you go to region by regions, if you go to the out of India regions, if every company have a different processes. So your software should be flexible enough to handle each and every processes. So business should not change their processes due to the software. Your software should be flexible so that everything should be handled with your software. When it comes to the SaaS product, there should be challenges like when you go to the different region, every region has a different compliances. You have to make sure that your software is compliant with every regions. Let me take you with an example. If you go to European regions, then there is a GDPR compliances. If you go to other regions, then there is a different compliances. You have to make sure that your software is compliant to all those policies of that regions. Apart from that, if you go to the other regions, people are not going to understand what terminology you are using over here. Every region has a different terminology. So your software should be understandable by every region users. So we given translations. We have given 18 plus languages, from French to German to Japanese. Every language our application is available. So if any user is using from Japan, they can use in their language. That make a software easy to understand and easy to use by that regions of users. When it comes to the availability into the regions, we have to consider that part also. Like when you are building a software for multi-regions, it should be available to that regions. So I was talking about compliances. So if you are developing SaaS product, it should be store the data on that region only. There are different compliances related to data protections, data privacy on every regions. So if you are building for Europe, then that whatever the user is going to come from Europe, their data should be stored in the European regions. If your user is coming from African regions, their data or their server is going to be on Africa regions. So we have to think beyond a single deployment. We have to think on multi-deployment. How exactly you build a software that should be available to all regions, which compliances all the region policy. That is also important when you start building towards a SaaS product.
Correct. So I wanted to go into the back-end old school days, like where the companies used to keep the data in their own office. Like I'm talking about on-premises, right? There are still big companies which are using this trend, right? So, and some of the companies are shifting their on-premises to the cloud. So, what are your thoughts on this? Like, why companies are shifting from on-premises to the cloud?
When it comes to the on-premises, you cannot able to scale beyond a certain limit. Let's say you have one system that you have bought, and that system has a 32 GB of RAM. Now, with the demand, you needed a 64 GB of RAM. How you will scale it? That is not possible with the on-premises server. When it comes to the cloud infrastructures, you can rent any server for any amount of time. If let's say in the future from 32 GB, you need a 64 GB, you can rent that server for whatever time. If you go with on-premises, then there is a lots of maintenance is going to come. Whatever server you are deploying, it should be secure enough. It should be reliable. So you have to think towards how you are maintaining the electricity, how you are maintaining the networking. All these things you have to think when it comes to the on-premises. But when you think towards the cloud, there is no such things. Everything is taken care by cloud providers. We just have to rent one server on a physical server, and just we have to pay the rent. And for whatever time we are going to use that server, we have to pay the bill. When it comes to the on-premises, that's not case. Once you buy the server, that will be stay for there. If you want to upgrade or if you want to do something else, that is not possible. Nowadays, when the AI is becoming mainstream, there is a needs of GPU. When you will need a GPU, how you will going to provision those things? When in the AI world, when you need a GPU, on premises, that is not possible. How you are going to purchase a biggest and biggest GPU? Now
Right.
AI is demanding the more power than ever. How you are going to keep it up with the demand?
Correct.
That is not practically feasible nowadays. Previously, people used to develop on premises, but nowadays there is not practically possible. You cannot able to handle that much complexity at all. And even if you do that things, it will start creating a problem. You will diverge from your main goal. Your goal should be develop a software. Your goal should be develop a business needs. And you start focusing towards maintaining and managing those infrastructures. That is not required at all.
Right, and here if we go with the on-premises, there is also multi-region or cross-region boundaries as well. If we have put the on-premises infrastructure in our office in India, but let's say we have an office in US as well, so we also have to put that same infrastructure in the US as well. So the scalability is very, very tough. Maintainability you have mentioned, and security as well. So comes toward the security, many of the people think that on-premises servers are secure. Are they?
No, on-premises server is not secure. Whenever there is some vulnerability which is going to discover, how you are updating those vulnerability, that is your responsibility. You have to constantly updating your software. You have to constantly monitoring your software. When it comes to the security, the cloud provider handle all those things for you. You don't have to worry about security at all, because there are many smarter people in the cloud teams. They are going to do that things. If you are doing on premises, are you having a proper team who understand a security in a proper way? If you don't have that team, then your on premises server is very risky. You might get attacked.
Vulnerable.
Then there is a vulnerability things you have to think about. Apart from that, there is a apart from that, what happens if your server get disaster? How you will recover from the disaster? So maintaining backup and all those things require extra engineering.
Yeah, right. So there is also one trend going on, like a few years back, server and serverless. So can you please explain a bit more on this topic?
So people usually think serverless means there is no server, but that's not true. Serverless means you have to pack your code in such a way that it should be run for bare minimum time. So what happens with the serverless is like you will rent it out server on milliseconds basis. How much millisecond you are going to use that server, you have to give the charge for that milliseconds only. When it comes to the spot instance, you have to give the bill for the day and night. Even though your server is not handling the traffic at night, you are paying that money for. But when it comes to the serverless, there is a totally different games. If you having 0 users, you are paying 0 rupees. If you having millions users, then your server scale with that demand. On every cloud providers, there are different type of serverless options are available. When it comes to the Google Cloud, they have Google Cloud Run. When it comes to the AWS Cloud, there is Lambda, there is Amplify. When it comes to Azure, there are different types of services available. What happens is that you have to build a code in a way that your code should be run on bare minimum time. You have to ship in the way that it should run on a micro container. When the traffic is going to come, cloud provider is going to give a provision server for you. And for whatever time, let's say your process needed a 10 second of time, then cloud provider is going to provision server for 10 second of time. Once that 10 second of work you're done, you will be have a no server. So that's the best things. And let's consider the scale. If you have a 0 users, then you are paying 0 rupees. And if you have a million users, then cloud provider is going to provision thousands of server at a time. So it's the best things.
So you're meaning to say that we have rented one computer, and no matter we are using it or not, so it's going to charge us. So that you mentioned that spot instance, right? And the serverless is when we have to use a server, on that time the server gets invoked, and only for that time we are getting charged, right? And everything is managed by cloud. Am I correct?
Yes, correct, Pratik. So what happens is, like, when you need a server, you request a cloud provider, okay, I need a server for this XYZ amount of time, or I need to run this my code. And cloud provider is going to provision that server for you. They're going to monitor how much time you have utilized that server for, and it's going to charge you based on that only. So once your work is completed, you will be charged 0.
That's
Apart
amazing.
from that, many cloud providers provide a GPU options on cloud on serverless. That's a good thing for if you want to build AI and ML related services.
That's
Because
amazing.
you cannot provision server for AI and ML for hourly basis. If you don't have a traffic, then it is going to cost you a large amount of money. If you don't want to do that, then what you can do, you can rent out a GPU server that is going to run your AI processes for a very small amount of time. Once your process is done, you free up the resources and you will charge whatever the time you have used for.
That's really awesome, amazing. So my next question is for non-technical viewers which are watching us. So if a non-technical person asks you, where does my data get stored on the cloud? So what will be your answer?
People usually misconceptualize cloud. Cloud is nothing but just one physical machine that we are renting on from the cloud providers. People usually misconceptualize the cloud. People think that there is something else is there, but the cloud is nothing. Cloud is like renting out one computer from the cloud providers. You will get one machine where your code is going to run and where your data is going to store.
Yeah, and that's connected to the internet.
Yes.
Yeah, that's really amazing. So let's come toward the final section of this podcast. So if someone wants to become a senior solutions architect, so what will be the mindset shift he needed?
The biggest mind shift changes is needed is you should start thinking about why we should build it instead of focusing towards how we should build it. We have to think about software at a whole. You don't have to think about your piece of code. You have to think how the software is going to be architected. You have to think about how the deployment is going to happen. You have to think about how the user is going to interact. How you have to think about scalability. You have to think about reliability. You have to think about security. When you start thinking about all of those things, it will become very easy that you will start progressing toward an architecture role.
Well, thank you, Mohammed. It's really nice to have you on this podcast, and thank you for your time.
Welcome, Pratik.